Hey, to finish up chapter 52, part 4, we are going to go through the aquatic biomes. So lakes. Obviously, lakes can vary from very small ponds to very large lakes, like the Great Lakes that we have in the United States. Temperate lakes may have a seasonal thermocline. So remember, thermocline was areas where deeper parts of the water are colder, and then you have warmer spots near the shallower areas. Um, but there are tropical lowland lakes that have year-round thermoclines. So if they don't have that traditional turnover like we saw, then the thermocline would exist for the entire year. Two different types of lakes, oligotrophic versus eutrophic. Oligotrophic lakes, nutrient poor and generally oxygen rich. Eutrophic lakes, nutrient rich and often depleted of oxygen in the very deep zones, or could be depleted throughout if it's covered in ice in the winter. So looking at a couple of differences here, you can see Jasper National Park in Alberta. Here's an oligotrophic lake versus a eutrophic lake in the Okavango Delta in Botswana. Wetlands are inundated by water at least some of the time and support plants adapted to water-saturated soil. They develop in shallow basins along flooded riverbanks or on the coasts of large lakes and seas. Wetlands are among the most productive biomes on Earth. Lots of plants and animals that live in these locations. So lilies, cattails, sedges, bald cypress, black spruce, diverse types of invertebrates and birds, otters, frogs, alligators. So lots and lots of variety. Often when we think of fish, reptiles, amphibians that live in those areas, they're very good locations to lay eggs because you can lay, the animals can lay the eggs or the fish can lay the eggs amongst the plants that live on the edges of the wetlands. Here's an example, basin wetland in the United Kingdom. Streams and rivers, most prominent physical characteristic, streams and rivers. Most prominent physical characteristic of streams and rivers is the current, so the movement of the water. Headwaters of streams and rivers, generally cold, clear, turbulent, and swift, and very oxygen rich. Often very narrow and rocky at the beginning of a stream or a river. Downstream waters form rivers that are generally warmer, more turbid, well oxygenated, and they're often wide and meandering and have silty bottoms. So the farther away you get from the start of the stream or the river, the wider it gets, the slower it gets, and the warmer it gets typically. So looking at differences here, so headwater stream in Washington. So again, you can see turbulent, rocky, narrower versus Loire River in France. Far away from its headwaters, very wide, very slow flow, probably as much warmer than you would find in this headwater stream. Estuaries. Estuary is a transition area between a river and the sea. The salinity will vary spatially and with the rise and fall of the tides. Estuaries are nutrient rich and highly productive. So complex networks of tidal channels, islands, natural levees, and mudflats will exist within estuaries. Here's an example of an estuary in southern Spain. So again, these are rivers that are leading out into the ocean. And you can see again that there will be tides that will come in, will rise and fall. So the salinity will vary based on the tides and what's going on here. Animals and plants that live in these estuaries have to be adapted to both freshwater and saltwater environments because the salinity does vary from time to time of the day, and also in seasons as well. Intertidal zones are areas that are periodically submerged and exposed by the tides. So sometimes they're underwater, sometimes they're not. The organisms that live in these areas, they're challenged by variations in the temperature, salinity, and the mechanical force of the wave action. So they have to be pretty good at withstanding the waves that pound upon them at varying times of the day. Oxygen and nutrient rich, and generally substrates will either be rocky or sandy depending on the location. Here's an example of a rocky intertidal zone on the Oregon coast. So look at all of these different invertebrates that are living in these areas. So very cool sea stars you can see, some mollusks here as well. So this is a time you can see when it is exposed to the air. It's not in water, but it will be underwater soon when the tide comes in. Ocean pelagic zone, that's the area. Again, the major portion of the ocean is the pelagic zone, constantly mixed by wind-driven ocean currents, very high oxygen levels, seasonal turnover in temperate oceans. Again, you have the photic zones, you have the aphotic zones underneath them. This is the biggest of the aquatic biomes. So this biome specifically covers 70% of the Earth's surface, the ocean pelagic zone. So that's good to remember in terms of the aquatic biome that is the largest. Phytoplankton and zooplankton are dominant organisms, again, very small. Phytoplankton in this pelagic zone account for about half of the photosynthesis on Earth. So again, think about just the dramatic effect of all of these organisms living in the sea. Fish, squid, turtles, and other marine mammals, dolphins, whales, are able to live in the pelagic zone. We know, again, major trouble for oceans having to do with overfishing. Pollution is a major factor. Acidification of the ocean due to carbon dioxide levels that are rising and being absorbed in the water as well. Open ocean near Iceland. So this is a whale breaching. Coral reefs. Coral reefs are very important. They're formed from the calcium carbonate skeletons of corals, which are cnidarians. Corals require high oxygen concentrations and a solid substrate for attachment. The coral reef can grow and change from a fringing reef to a barrier reef to a coral atoll, which is a beginning of an island. Corals will form a mutualistic relationship with unicellular algae, which provide them with organic molecules. In addition to corals, the other invertebrates and fish are exceptionally diverse, and coral reefs really are very, very important in terms of acting as a nursery for many other species of organisms that live in oceans. So the loss and bleaching of coral reefs is a major problem for the diversity of life in the oceans. Here's a coral reef in the Red Sea. Look at all these beautiful fish and all the corals and different algae and other invertebrates that are living in and among the corals. Marine benthic zone, that would be the seafloor below the surface waters of the coastal or neritic zone, and the offshore pelagic zone. Organisms in the very deep benthic zone, again, the abyssal zone it's called as well, are adapted to continuous cold and extremely high water pressures. The deep sea hydrothermal vents of volcanic origin on mid-oceanic ridges are surrounded by unique chemoautotrophic protokaryotes, as well as echinoderms and arthropods. These deep sea hydrothermal vents are actually potentially one of the sites of the universal ancestors. So here's an example of a community living near a deep sea hydrothermal vent. These are good places for organisms because, again, there is a decent amount of nutrients that are coming up from the vents, but also the warmth, the heat that is coming from the vents as well would allow for life to exist. Outside of these hydrothermal vents, it's much, much colder. And again, the nutrients are much lower. So this is a great place in these very deep abyssal zones where you can have life that will actually form and be maintained. even away from the photic zone. So this would be the aphotic zone in the ocean where sunlight does not reach. And that's it for chapter 52. Hope you enjoyed learning about it, and I will see you all soon. Bye-bye.